First concept you have is naming acids and bases. So we had two acids, binary acid, and then the oxyacid. Binary acid means what? You have a hydrogen and anion. So it doesn't, just a hydrogen and an anion. So, oh, I shouldn't say that. Let's say not an anion. Let's put nonmetal. Because it's a single element. Polyatomic ions are anions also, but we're looking at just a single element. So hydrogen and one other element. And if we have a binary acid, we add the hydro prefix. And then we have the ic ending. So an example would be HBr. We have hydrogen and one other element. What would be the name? Hydrobromic acid. Okay, oxyacid, you have hydrogen and a polyatomic ion that has oxygen in it. And here, if let's say the anion, so if you looked on your chart, on your ion chart, and the anion, the polyatomic ion had an ITE ending, what would the acid name have as an ending? And if it has an ATE ending, it's ic. You don't change any of the prefixes, so if the anion already has a prefix added, like hypo or per, you just leave that in the acid name also. So HClO would be what? Do we use hydro? No, because we have oxygen in it, we don't have to use hydro. So you would just look up ClO. ClO is hypochlorite. So what would be the name? Hypochlorous acid. Let's see, I'm going to write that is hypochlorite. Yeah. What?
Do these ones all have hypo instead of hydro?
No, it's just because ClO has hypo in it. If we had ClO3, the ClO3 is chlorate. So then this would be chloric acid. We just change the ATE to IC. So the hypo is only in the hypochlorous acid because ClO is hypochlorite. You don't have to change any prefixes.
Up there, you have like oxalic acid,
Hydrogen and the polyatomic ion that has oxygen in it. So the polyatomic ion has to have oxygen, yeah, with oxygen. Okay, and then bases, what do bases have in them? We have the OH ion, and what's OH called? Easton, what's OH?
I don't know.
Hydroxide. Hydroxide. So it would be a metal hydroxide. Make sure you always still change the charges. Hydrogen has a +1 charge, so make sure you're crossing the charges, balancing out charges. Hydroxide's -1, so if it's with a +2 ion, then it needs to have a parentheses 2. Right. Questions on naming acids and bases? Okay, acid-base conjugate pairs. First, you have to determine what's an acid, and I think, only the one. Let's say we have so we have that equation, that reaction. Which element, which reactant acts as an acid? Why? All right, so this is our acid, and acids donate protons. So it started out as H2SO4, it ended as HSO4-, so it has lost a proton. So this reactant donated a proton, so that makes hydrogen a base. Which one would be our conjugate base? This is our conjugate base. So acids, after the acid has donated the proton, what's left is called the conjugate base. The base, after it's accepted a proton, that's called the conjugate acid. And if you think about if it's going the opposite way, so let's say we're going from the right to left, in order to go from HSO4- to H2SO4, you have to gain a proton, you have to gain a proton, so it has to act as a base to go backwards. So that's why it's called a conjugate base. So the acid is paired with the conjugate base, the base is paired with the conjugate acid. Questions on finding those pairs? Questions on what acts as an acid or a base? Okay. Mm-hmm. No, because if we did, let's say, you can get right. It depends on what happens to it. If it becomes H3O+, then it will be the base. If it becomes OH, then this one, water, is an acid, and this is our base. So you have to look at what happens to it. What does it do? Does it gain or lose protons? Okay. On the bottom, add molarity. Calculating molarity, because we learned that in this chapter. Molarity was equal to moles over liters. So you have to make sure the volume is in liters. So whenever you see the brackets around OH minus or plus, that is the molarity usually. Of hydroxide, the concentration of hydroxide. Do you want to go over any problems about calculating molarity? Yeah? Let's say, how many grams of salt do we have? 12. And what's its mole concentration? 0.5. Oops, not grams. So we have a 0.5 molar solution, and we know that we dissolved 12 grams of 12 grams of sodium chloride in that solution. So how many liters of water did we use? Or if we want to make 0.5 molar solution using 12 grams of sodium chloride, how much water should we measure out? We would do what? Change grams to moles. And from the periodic table, it's 58.45. I don't know what that is when you divide it, though. So 0.21 moles. Now what? Put in the top equation. So what's our molarity? 0.5 is equal to 0.21 over, we're looking for liters, 0.21 divided by 0.5. So measure out 0.42 liters or 420 milliliters. Add your 12 grams. Questions on the molarity? I should connect the box. Does that bother you? Oh.
How would you know if it's molarity or
Big M, if they have a big M, that's molarity. Moles is usually MOL. So then going back up to calculating hydronium concentration and pH, we have all those equations. So if we know the hydronium concentration, if we want to find the pH, I guess. How do we find the pH? Negative log of, I think I'll have them on a sheet for you. I'll give you these equations. And sometimes you could see it be negative log of just the H plus. Means the same thing. H3O plus and H plus are interchangeable. POH is the negative log of the hydroxide concentration. If I add those two together, what do you get? Oops. 14. You always get that. So if you know the pH, you should be able to find the POH. And then if you have if you know the pH, how do you find the hydronium concentration? The negative pH. And pH a lot of times has a decimal, but don't leave decimals in the exponent, so actually put it in your calculator, push equals, and write down that number that it gives you. You want an integer in the exponent. And then we can do the same with hydroxide, same process. And then what does the product of those two concentrations equal? And that value is called Kw. I think that's all of them.
What's KW?
The ion product constant of water. It's 1 times 10 to the negative 14th.
This is the random number, or
It's always because pure water is neutral and the concentrations of,
so where did they get the KW?
Just made it up.
no, the concentration in water, concentration of hydroxide and hydronium are each 1 times 10 to the negative 7th. So when you multiply those two together, you get 1 times 10 to the negative 14th for water.
Prefix KW.
Why Kw? I don't know.
Well,
There's
I know one.
There's constants. There's the acid constant is Ka. Acid constant is Ka. Base constant is Kb. We didn't study those, but what?
I know.
You guys want to go over problems of using those equations? I'll give you those equations.
How do you know, like,
I don't know what to look for.
Yeah.
I mean, would you? Sure.
how do you know why we play negative 14?
I would write down all that you know. So let's say you know the pH. It tells you in the problem, it tells you the pH. And it wants to know hydroxide concentration. Are there any equations that have both of those in it? No. So, right, you're going to have to find, so you know this one, so let's call it 4.7.
I don't.
DOH, which is 9.3.
Right. So there's actually a couple different ways you can do it, but you need to be able to get to where you can find this concentration, or you could use this equation too. These are the two equations that have hydroxide concentration in it. And this one, I guess. So, in order to use this equation, you need to know pOH. And so to find pOH, you're going to use this equation. So take 14 minus that, and then plug it into this equation to get OH minus. Or, how else could we do it? If we use this equation, we need to know hydronium concentration. If we know the pH, we can find hydronium concentration using this equation, plug that into here.
So they're,
Right, so-
they're either going to give you a H3O, an OH, or pH.
Or pOH. Yep. They'd have to
It'll
give you
say
something.
that.
Yes.
So it's like the pOH of this is this. It's not going to be like, oh, there's 84 moles in this thing, and then that's going to be that. Then you got to switch it to this, and then that's going to be that.
No, but it might just say, it might not say H3O plus, but it might say hydronium concentration is such and such. And that's 3O
You can't
plus.
do it in one thing. You have to do it 30 times to get it to that.
I don't think
Well,
so.
Like, there would be 4 moles, and then you got, I don't know.
Maybe it'll say there's 4 moles of hydronium per liter.
Yeah, like how.
So then you know, then you'd have to use your molarity equation. So I'll give you this equation too, but if it's like 4 moles per liter, it'd be 4 moles per liter is equal to 4, and that was how many moles of hydronium, so then that's 4 would be equal to this value, the hydronium.
So then the 4 would be H3O plus.
Yep. I guess that's one other way they could give the problem to you. So I'll give you this equation too.
Why is this really confusing? Why'd you save the hardest chapter for the last one?
I don't think it's the hardest.
This chapter's hard. So anyone else change last chapter?
You know, you should save like the easiest chapter for us. Let's just skip it, go to this one, and then come back to the easiest one at the end.
What was the easiest one
Ones that you could actually study.
Like the first one of the semester.
of the semester? What was that?
First one of the year.
Year? No, this one was semester.
The mold one was half
Chapter
the
I don't
one.
know what hard to know like this.
The one with the mold.
The one with the moles?
You
There's-
know mold.
Yeah.
I don't know. That's something we need to figure out.
Okay, I'll take that into consideration, Kurt.
Just go back into each one and go and bump the highest grade on. The class average is the highest. That's probably easy.
See if you can fit that.
Strengths of acids and bases. You guys don't have to know the strong acids and bases.
So we
We
can just
don't?
cross that off?
So cross that one out.
So you don't have to know the strong acids. You wrote it on the notes. Because I
Shh, Valley.
You're complaining.
wrote that she's not gonna like change your mind or
Well, Sonic says she's gonna have to get rid of it.
Titration problems. So this is what we did in our lab, right?
Yeah. I wasn't here for it.
Yeah. So I think we should just do a problem.
You can just start over. Or just
Let's use our two acids we used. HCl plus NaOH. What did that yield?
H2Cl.
Give me a volume of hydrochloric acid.
24.
I heard 24 first. Milliliters, probably. 24 liters is a lot. What molarity of hydrochloric acid?
Not 13. 13 is a bad number.
17.
12.
0.12? Then? That work?
Yes.
And we want to know, we don't know the molarity of our sodium hydroxide, but it took how much? 13 milliliters? Yep, so what do we do? We're going to use our M equals M moles over liters, so we'd have 0.12. We're looking for our moles, because once we know the moles of hydrochloric acid we have, we can calculate how many moles of sodium hydroxide it took to neutralize. They should be, since it's a 1-to-1 ratio, the moles will be equal. .024, right. Don't forget to change this to liters. So this would be 0.024 liters. This is 0.013 liters. So how many moles?
0028.
So this step is an easy step because we know it's a 1-to-1 ratio, but let's write it in here anyways. Because 1 mole of HCl requires 1 mole of NaOH. Let's say we used H2SO4. We would have had a 2 here then. we would have ended up having to have a 2 here, and so we would have a 1-to-2 ratio. This depends on what kind of equation, what kind of acid you use, what your coefficients are. For this equation, it's 1-to-1. Makes it easier. So 288 moles of NaOH. And how do we find molarity then? Our moles over liters. Our liters of hydroxide, or sodium hydroxide. I don't know what that is.
I'll do it.
Okay.
0.22 molar. There you go. Questions? I guess the one thing I assume that we know here, what's always the product of a neutralization reaction? So this is a neutralization reaction. What's always the product? Water, H2O, and then the salt. It's a double displacement reaction. Right. When you add an acid with a base. So any questions, anything you want to go over from the chapter? A worksheet?